week 11 of quality quant questions. In this week, we'll be taking up 4 more TSD questions because TSD as an area is very widespread and we need to be practicing all sorts of questions that come from TSD. Okay, so let's go. 3 runners, A, B and C run a race with runner A finishing 12 meter ahead of runner B and 18 meter ahead of runner C, while runner B finishes 8 meter ahead of runner C. Each runner travels the entire distance at a constant speed. What was the length of the race? Okay, say the full distance was A. When A is at the finishing line, B is 12 meters ahead of A and C is 18 meters behind A. So right now, because they are running for identical amount of time, can I say the distance run by B and the distance run by C will be in the ratio of the speeds? So let's say the full track length was x minus 12 by x minus 18 is the ratio of the distance and also the ratio of the speeds. Later on, when B finishes the race, C is 8 meters behind B. Again, the ratio of the distance will now be x by x minus 8. And upon solving this, we should be able to arrive at the length of the race. X square minus 20x plus 96 is equal to x square minus 18x, or 2x is equal to 96, or x is equal to 48. This is one way of solving this, and this is the traditional way. Another way of solving this is also, look at this. In the time that B has run this remaining 12 meters of distance, in the time that B has run this 12 meters of distance, C has run 10 meters of distance. Previously he was 18 meters away from the finishing line, now he's 8 meters away from the finishing line. So I can directly jump to ratio of speed of B and C is 12 by 10. This is equal to x by x minus 8. This will lead us to 12x minus 96 is equal to 10x, or 2x is equal to 96, or x is equal to 48. This way also we can arrive at our answer. The first one is the traditional way, second one is slightly smarter. Another time and work based way that you can see is, see, when A finished the race, B was 6 meters ahead of C. When A finished the race, B was 6 meters ahead of C. Now, in the time that B runs 12 meters, when B runs 12 meters, in the time that B runs 12 meters, he has increased his lead over C by 2 meters. 2 meter lead is generated. When B runs 12 meters, 2 meter lead is generated. At the end, they have an 8 meter lead, which would mean B has run so far 48 meters, which is the length of this race. Or option B will be the right answer here. Okay. Next question. Ram and Shyam run a race between points A and B 5 kilometers apart. Ram starts at 9 a.m. from A at a speed of 5 kilometers per hour, reaches B and returns to A at the same speed. Shyam starts at 9:45 a.m. from A at a speed of 10 kilometers per hour, reaches B and back to A at the same speed. At what time does Shyam overtake Ram? The question is, at what time does Shyam overtake Ram? Okay. Now see, diagrammatically, you can think of this as Ram is running this way and coming back somewhere here. This is Ram, and Shyam is moving this way. He's running this way and coming back. The point where the distance traveled by both of them becomes identical, that is the point where Shyam will overtake Ram. Now if distance traveled by both of them is identical, the ratio of speeds will be the inverse ratio of times. Speed of Ram to speed of Shyam ratio is 1:2. So time for Ram is to time for Shyam should be 2:1. Now I know the difference in their times is 45 minutes, which means Ram has run for 1 hour 30 minutes and Shyam has run for 45 minutes. So at what time will Shyam overtake Ram? 1 hour 30 minutes after Ram started, or from 9 am we go 1 hour 30 minutes forward, we get to 10:30 am, or 45 minutes forward from 9:45 am when Shyam started, we get to 10:30 am. Okay. Next question. Karan and Arjun run a 100-meter race in which Karan beats Arjun by 10 meters. So, in the time that Karan runs 100 meters, Arjun runs 90 meters. So, the ratio of the speeds is 10:9. Speed of Karan is to speed of Arjun is 10:9. They are running for identical amount of time. Karan starts 10 meters behind the starting line in a second 100-meter race. So in this race, Karan is running 110 meters and Arjun is still trying to run 100 meters only. They both run at their earlier speeds. A runs at the rate of 10, A runs at the rate of 9. Okay, which of the following is true in connection with the second race? Now, given that they are running at the same speed, the ratio of distance covered by them, this is the race length. The distance covered by them will continue to be in the ratio 10:9. So by the time Karan has covered 110 meters, Arjun would have covered 99 meters, or he's still 1 meter away from the finishing line. So who will win the race? Karan will win the race and he will beat Arjun by 1 meter, or option D is the right answer. Next question. A and B start from two locations P and Q respectively at the same time and meet every day at X on the way. Uniform speeds of A and B are 20 km per hour and 15 km per hour respectively. One day, B starts T minutes late and meets A 5 kilometers ahead of X at Y. Find T. Okay. So let's say the journey on which they meet is something like this. This is P, this is Q. A moves this way, B moves this way, and they meet at some point X in between. Let them meet every day at, let's say, noon, 12. Let them meet every day at 12 p.m. Okay. Now, on one particular day when B was late, they met at Y. This is 5 kilometers to the right of X. Now understand, on the day that B is late, he would be somewhere here at, let's say, point Z. B is at point Z at 12. B is at point Z at 12. Now, in the time that A covers XY, B has covered ZY. In the time that A has covered XY, B has covered ZY. Okay. How much time will A cover XY? 5 kilometers at the rate of 20. A will cover this distance in 15 minutes. So B will cover this distance in 15 minutes. Which means on this particular day when they meet at Y, they met at 12:15. When they met at Y, they met at 12:15. Now more wonderful. If B had not been late, he would have arrived at X at 12 p.m. If B had not been late, he would have arrived at X at 12 p.m. How much time will it take? This is the time when A and B both are here at Y. This is the time when B is at Z. This is the time when A is at X. At what time will B reach X? At what time will B reach X? He has to cover 5 kilometers at the rate of 15. So B will take 20 minutes. He was at Y at 12:15. He will take 20 more minutes. So he will reach this point at 12:35. B will reach X at 12:35. When B starts normally, he reaches X at 12. On this particular day, he reaches X at 12:35. So how much late was he in starting? He was late by 35 minutes. Okay, next question. A and B stay in the same apartment and study in the same school. A and B start walking towards their school at the speed of 2 and 3 kilometers per hour respectively. The faster of the two reaches the school first, turns around and starts walking back. If A and B meet 200 meters away from home, then what is the distance between their apartment and the school? Let's say this is where their apartment is, this is where their school is. Now the slower guy is walking this way and the faster guy is walking. He reaches school and starts traversing back. Let's say this is where they meet. Now understand, this is 200 meters. This is 200 meters. The faster guy has traveled x and x more. From this point where they meet to the school, x meters if I take. Now, because they have been traveling for identical amount of time, the ratio of distance covered by them will be in the same ratio as the speeds. So 200 by 200 plus 2x is going to be equal to 2 by 3, which gives us 600 is equal to 400 plus 4x, or x will be equal to 50. So this is 50, this is 50. Finally, we have been asked what is the distance between their apartment and their school? 200 plus 50. The distance between the apartment and their school is 250 meters, or option D is the right answer. Okay, next question. And this is one of my favoriteest questions, because if there is a very smart way of managing this. PQR start from the same place at x kilometers per hour, from same place x at a kilometers per hour, a plus b kilometers per hour, a plus 2b kilometers per hour respectively. If Q starts t hours after P, after how many hours Q and R should start so that both Q and R overtake P at the same time? A is greater than 0, B is greater than 0. Absolutely fine. And then all the four options that are given to us, are in variable terms. This should be a trigger. We can assume any values, and still our answer will be achieved. So what I am doing is, I am saying let P have a speed of 1, A is 1, B is also 1, so Q has a speed of 2. I have taken A equal to 1 and B equal to 1, and R has a speed of 3. P has a speed of 1, Q has a speed of 2, and R has a speed of 3. Now if all of them are reaching the same point at the same time, if Q and R overtake P at the same time, can I say let that distance be 3 kilometers itself? So P traveling at the rate of 1 would have traveled for 3 hours. Q traveling at the rate of 2 would have traveled for 1.5 hours. And R traveling at the rate of 3 would have traveled for 1 hour, so that all P, Q and R reach this point simultaneously. What this also does is, see, if Q starts P hours after P, do we know RP is equal to 1.5 now? After how many hours should Q start after R? The answer that we are seeking is 0.5 hours. The answer that we are seeking is 0.5 hours. Now, all I have to do is go back in here and plug in the values for variables that we have identified. Wherever we get 0.5, that will be our answer. So for the first one, I get 1.5 divided by 2. This is not equal to 0.5. So this is wrong. Here I get 1 divided by 1.5 into 2, or I get 1 by 3. This is also not right. Here I get 3 divided by 3, which is equal to 1. This is also not right. Here I get 1.5 divided by 3, which is indeed equal to half. And this is what we were seeking. The answer to this question should be option D. Now in some instances, what may happen is more than one of the options might end up giving you the right answer. In such cases, all you have to do is, let's take slightly different numbers. This time I was keeping the distance from the starting point to the meeting point 3 kilometers. In the next instance, I will keep it as 6 kilometers. When I keep it as 6 kilometers, then my numbers will change. When my numbers change, I go back and the two options or two or more options, wherever I was getting the same result, wherever I was getting half, I plug in the numbers again, and this time it will most certainly leave me with only one option available, and that will be the answer. But here, the trigger or the learning point that I want you to take away is simply the fact that because all the options are in variable terms only, these variables can be given any value. It is much easier if you give value to these variables instead of dealing with them algebraically. Okay. Next question. P beats Q by 20 meters in a 120 meter race, which means speed of P is to speed of Q, because they're running for identical time. 120 and 100 is 6:5. And Q beats R by 24 meters in the same race, which means speed of Q is to speed of R should be 5:4. Okay. Now if I combine this, speed of P is to speed of Q is to speed of R should be 6:5:4. By what distance will P beat R in a race of 150 meters? P will win when he gets to 150 meters. This is into 25. In that time, he would have run 100 meters, or the distance by which P beats R is going to be 50 meters. Next question. In a kilometer race, Ram beats Shyam by 1 minute and Shyam beats Tarun by 30 seconds. This is a wonderful way of saying Ram beats Tarun by 90 seconds. The time taken from Ram to Shyam to Tarun is 90 seconds. So Ram beats Tarun by 90 seconds. If Ram beats Tarun by 250 meters in the same race, we have also been told Ram beats Tarun by 250 meters, which is to say Tarun runs 250 meters in 90 seconds. And this is a kilometer race. Tarun runs 250 meters in 90 seconds. Because this is a kilometer race, can I say Tarun runs 1000 meters in 4 times the distance, so 4 times the time? He runs the entire race in 360 seconds. And we also know Ram beat Tarun by 90 seconds. So Ram himself would have taken 270 seconds, 90 seconds less than Tarun. Find the time taken by Ram to run the race. The answer will be option B, 270 seconds. Okay. Next. In a race, Mohan beats Soham by 40 meter and Sohan beats Rohan by 80 meter. Mohan beats Rohan by 104 meters. Now this is a very simple question. A very simple question. In fact, this is nothing but the first question, just that the order of information has changed. See what has happened. Mohan, Sohan and Rohan. This gap here is 40 and this gap here is 104, which is another way of saying Sohan is currently beating Rohan by 64 meters. Sohan is currently beating Rohan by 64 meters. But when the race ends, Sohan is here and Rohan is here. He has beaten Rohan by 80 meters. So in the time that Sohan runs 40, Rohan has run 24. So 40 by 24 is equal to length of the race being x divided by x minus 80. This gives me 5, this gives me 3. I get 5x minus 400 is equal to 3x, or 2x is equal to 400, or x is equal to 200. The length of the race is 200 meters. Okay. Next, 2 persons R and S had to meet at a place 36 kilometers from where they were at that moment. So they both have to travel 36 kilometers. S, who was given a head start of 2 hours, reached the destination 12 minutes earlier than R. If R traveled 18 kilometers per hour faster than S, at what speed did R travel? Okay, let's see. Distance for R and S. Distance for both of them is 36. Speed, R traveled 18 kilometers per hour faster than S. So if I say the speed here is R, the speed here is R minus 80. Now the time here will be 36 by R, and the time here will be 36 by R minus 18. Now understand, this fellow was given a 2-hour head start. This fellow was given a 2-hour head start. Because of that, what would happen is, the time taken here, this fellow was given a 2-hour head start and he reached the destination 12 minutes earlier than R. So let's say 36 by R plus 2 minus 12 minutes, so 1 by 5 is equal to the time taken by S, which is 36 by R minus 80. This is what we have got. So 36 by R plus 9 by 5 is equal to 36 by R minus 80. I can get rid of 9s from everywhere. This becomes 4, this becomes 1, this becomes 4. Now 20R minus 72, sorry, 5, not 72, 5 into minus 18 into 4. So minus 360 plus R square minus 18R is equal to 20R. This is what we've got. This and this goes away. I left with R square minus 30R plus 12R minus 360 is equal to 0. So R minus 30 or R plus 12 is equal to 0. So speed of R is equal to 30 or minus 12. Clearly the speed can never be negative. So answer to the question has to be option C. Next question. And from this point onwards, we will have circular motion or circular path questions here. Ram, Sham and Tarun started cycling from a point on a circular track 600 meter long with speeds of 10 meter per second, 15 meter per second, 20 meter per second respectively. Find the time taken by them to meet at the starting point for the first time. In order to find the time taken by them to meet at the starting point for the first time, we need to find out time for one entire round. For the first person, it is 60 seconds, 600 by 10. For the second person, it is 40 seconds. And for the third person, it is 30 seconds. First person, after every 60 seconds, he'll be at the starting point. The second person, after every 40 seconds, he'll be at the starting point. The third person, after every 30 seconds, he'll be at the starting point. Now, when are they going to be at the starting point? At a common multiple of these. At a common multiple of these, LCM of these three numbers is 120. So time taken by them to meet at the starting time for the first time is going to be 120 seconds, or option A. Next, Prakash and Pramod are running along a circular track having started at the same time from the same point in the same direction. They're running in the same direction. Now, if you know nothing else about circular motion, just know when they're traveling in the same direction, they will meet when the faster guy has taken one more lap than the slower guy. Okay. How much more distance would Prakash have traveled compared to Pramod by the time they meet for the 11th time, given that the radius of the track is 7 meters and Prakash and Pramod run at 22 meters per second and 11 meters per second respectively. Okay. Because they are meeting for the 11th time, the faster guy would have taken 11 more rounds. 11 more rounds would be 11 times the circumference of the circle. The circumference of the circle is 2 into 22 by 7 multiplied by the radius. Understand, in these numbers, the speeds of Prakash and Pramod were irrelevant, absolutely irrelevant. The faster guy has taken 11 more rounds than the slower guy, so the difference in the distance traveled by them is 11. 11 times the circumference of the circle, 11 times the circumference of the circle. Their speeds has absolutely no role to play here. We get rid of this 7, we get 11 into 2, 22, 22 into 22. The distance that Prakash has traveled more than Pramod is going to be 484 meters. Next question. P and Q started moving simultaneously from point X and Y respectively on a circular track in the same direction. Okay, so let me have a circle drawn first. Okay. This is P. XY is 2 kilometers and the length of the track is 6 kilometers. So let's say this point is X and this point is Y. 1/3 the distance, because 2 kilometers and 6 kilometers, this is 1/3 the distance. Y is here and Q is here. They're moving in the same track in the same directions. Okay, this and this. This is how they are moving. The initial position of P was behind that of Q. Q is chasing P. Okay. P caught up with Q for the second time in 40 minutes. Now this is interesting. See, for the first time, for P to catch up with Q, he has to travel 1/3 the track length. For the first time, for P to catch up with Q, he has to travel 1/3 the track length. And for the second time, for P to catch up with Q, he has to travel the full track length. So 4/3 times the track length has been covered in 40 minutes. 4/3 times of the track length, the difference in distance traveled by P and Q has to be 4/3 times the track length, and this has been covered in 40 minutes. Okay, so can I say the speed with which P is catching up with Q is the difference of their individual speeds. So 4/3 times of track divided by P minus Q is equal to 2/3 of an hour. 3 and 3 goes away, 2T, or P minus Q is equal to 2T, where T is the variable for the entire track length. Okay. Next, we are told, had P started in the opposite direction, they would have met for the first time in 12 minutes. If P had been running this way, if P, 2 times the track length, I already know the track length is 6, no? So I can go P minus Q is equal to 12. From this I can get to P minus Q is equal to 12. Now if P was running in the opposite direction, for them to meet for the first time, they would have traveled 4 kilometers. 4 kilometers traveled at the speed of P plus Q would have taken 1/5 of an hour, or this gives me P plus Q is equal to 20. P minus Q is equal to 12, P plus Q is equal to 20, which would mean P is equal to 16 and Q is equal to 4 when P and Q are individual speeds. Finally, they've asked me find the speed of P in kilometer per hour. Speed of P will be 16 kilometers per hour. Okay. Next, Amar, Akbar and Anthony start running in the same direction from the same point around a circular track with speeds 8 meter per second and 11 meter per second and 22 meter per second respectively. Akbar can complete 5 revolutions around the track in 48 seconds. So 40 seconds. When will they meet for the first time after they start? Okay. First thing, we can figure out the length of the track, the circumference of the track. 5 revolutions in 40 seconds means 1 revolution in 8 seconds. And in 8 seconds, distance covered by Akbar. Akbar is the second fellow. So 88 meters is the circumference. Now see, because they're running in the same direction, how often will Amar and Akbar, the first 2 people, meet? They'll meet after this much time. This is for Amar and Akbar. How often will Amar and Anthony meet? They will meet at 88 by 22 by 7, 22 minus 7. Amar and Anthony. And finally, it would be Akbar and Anthony. They would meet after 88 by 22 minus 11. Every 88 by 4 seconds, Amar and Akbar meet. Every 88 by 15 seconds, Amar and Anthony meet. Every 88 by 11 seconds, Akbar and Anthony meet. So for all three of them to meet simultaneously, an integral multiple of these times has to pass. So we are looking for LCM of these numbers. LCM of fraction is LCM of numerators, which is 88, divided by HCF of denominators. 4 and 15 have an HCF of 1. So 88 by 1. They will meet after 88 seconds. Now one point of clarification. I did not really need all the three pairs here. I did not really need. Any two pairs would suffice. But I encourage people to do all three pairs. in order to find the common meeting point of all the three people, for the simple reason that it ensures that the calculation that you've done is appropriate. This is an added layer of check. So in the practice phase, I would heavily encourage you to do it, and this will help you potentially miss out on errors in future. Okay, next question now. P and Q are 2 points on a 1 kilometer long circular track. Okay. P and Q are 2 points on a 1 kilometer long circular track. The distance PQ along the track is 200 meters. So 1/5, let's say Q is here. This is 200 meters. Rohan started running from P. Sohan started running simultaneously in the same direction from Q. Both reached P for the first time simultaneously. Okay. Rohan started running from P. And Sohan started running from Q in the same direction. Now this is one case where Rohan is going this way and Sohan is also going this way. This would imply Rohan has covered 1000 meters in the same time that Sohan has traveled 800 meters. So speed of Rohan is to speed of Sohan is in the ratio 5:4. But this is not all. The problem is, it could very well be that both of them are running in inverse direction like this. So in the time that Rohan has run 500 meters, Sohan has run 200 meters. Okay. So speed of Rohan is to speed of Sohan is equal to 5:1. This is one possibility. Speed of Rohan is to speed of Sohan is 5:4, and speed of Rohan is to speed of Sohan is 5:1. Okay. Both reach P for the first time simultaneously. If both started simultaneously from P in opposite directions, they would take 111 seconds to meet for the first time. Okay. If they both started simultaneously from opposite direction from P. Under this working, if I take speed of Rohan as 5x and speed of Sohan as 4x, for them to meet, they would have cumulatively traveled 1000 meters. 1000 meters traveled at the rate of 9x is equal to 111 which is 1000 by 9 only, which means x is equal to 1 meter per second. Speed of Rohan is guaranteed to be 5, speed of Sohan is guaranteed to be 4. On the other end of the spectrum, we have this 1000 divided by 6x is equal to 1000 divided by 9, which means x is equal to 1.5 meters per second, which means speed of Rohan is 7.5 and speed of Sohan is 1.5. Okay. Now find the time taken by them. Find the time taken by them to meet for the first time in seconds if they started simultaneously from Q in the same direction. If they started from Q simultaneously in the same direction, in this case, the difference in their speeds is 1 unit, and the faster guy has to travel 1 lap more or 1000 meters more than the slower guy. So 1000 divided by 1, in this case it would take him 1000 seconds. In this case, it would take him 1000 divided by 5, 200 seconds. And which of these is the right answer? Both are right. Both are absolutely right. Both these outcomes, both these scenarios are possible. And therefore, in the answer key, you have 1000 or 200 mentioned. Because it is not specified who is behind. Like in the previous question, here the initial position of P was behind that of Q. This was specified, and therefore we got a unique answer here. Here we were simply told both Rohan and Sohan are running in the same direction. Both Rohan and Sohan are running in the same direction. So because we don't know who is in the front, who is in the back, both these cases exist. Because both these cases exist, both these answers can also come. If such a question appears in the exam, everyone who has reached 1000 or 200 will get full marks. Every other answer will be deemed incorrect. But hopefully you learned something. This twist was fun for you. Next, two persons start cycling simultaneously from a point P on a circular track. If they travel at speeds of 3 km per hour and 10 km per hour respectively, then what is the ratio of number of distinct points that they would meet on the track when they travel in the same direction first to that when they travel in the opposite direction? This is fairly straightforward. We know the ratio will be 10 minus 3 is to 10 plus 3, or the final ratio will be 7 is to 13, or option A will be the right answer. Okay, next. Chiku and Charu are running along the circular path with a diameter of 1050 at the speed of 15 meter per second and 25 meter per second respectively. Chaman is running along the path AB, diameter of the circular path, at the speed of 35 meter per second. Chaman turns back immediately after reaching point B and does the same as he reaches point A. All of them start from point A simultaneously. Before we get to solving, we should understand what is the storyline that is being told to us. Let's see, not this. Let's say this is point A and diametrically opposite, this is point B. Now, Chiku and Charu are running along the circle, but our third fellow Chaman is running to this point. Chaman is going back and forth here on this diametric line, and Chiku and Charu start from A and they run along the circumference. Where exactly, as in which direction are they running in? We don't know. We'll see from the question. We have Chiku here, Charu here. All of them start from A simultaneously. Even Chaman starts from A simultaneously. Okay, next. If Charu and Chiku are running in the opposite direction, okay, Charu and Chiku are running in the opposite direction. Chiku is running at the rate of 15, Charu is running at the rate of 25. Okay. Now we were also told the diameter of this circle is 1050. Now circumference of a circle is given by pi d, which is not a usual thing to hear. Just remember, the circumference of a circle is 2 pi r, and 2 r is good as d. So pi d, we can directly get to there. Pi d, which should be equal to 22 by 7 into 1050. This was the diameter. Cancel, 150, or the diameter is 3300. Yes, 3300. If Charu and Chiku are running in opposite direction, their speeds are 15 and 25. What is the shortest distance in meters along the circular path between point A and the point at which Charu and Chiku meet for the third time? When they have met for the third time, when Charu and Chiku have met for the third time, they have cumulatively traveled the circumference of the circle 3 times. So they have traveled 9900 meters. They have traveled 9900 meters. If they have traveled 9900 meters, the ratio of distance traveled by them will be the same ratio of the speeds, which is 3:5, which is 3:5. So 3 by 8 into 9900 would be the distance traveled by Chiku, and 5 by 8 into 9900 would be the distance traveled by Charu. Okay. I am going with 2, and this 9900 I will write it as 99 into 25. So 125 into 99. 125 into 99 I am getting, and here I will get 99 into 25, 75 into 99. 75 into 99 will be how much? 7500, 7425. Divided by 2, and here 125 into 100 is 12500, 12375. 12375 divided by 2. This gives me 3712.5. 3712.5, and this gives me 6 and 1 and 8, 7.5. Chiku has traveled 3712.5 and Charu has traveled 6187.5. Understand, if Chiku has traveled 3712.5, Chiku has traveled one full circle and some extra part, one full circle and extra part. Finally, we were looking for the shortest distance along the circular path. So in order to arrive at the answer, I should simply be subtracting 3300 from this, which will get me to my final answer of 412.5. In this case, if I subtract 3300, why I have done the entire working I wanted to show you, 6187.5 minus 3300, I will get 0.578, and here 2887.5. But understand, this is being measured along this path. Here will be the point that they meet, somewhere here will be the point that they meet. The question was asking me the shortest distance, so I can't take this distance. I'd have to subtract, or from 3300 I'd have to subtract this number in order to arrive at 412.5. The shortest distance between the starting point and the point where they meet for the third time is 412.5. Both these numbers can lead us there. It is just that it takes a little bit of more nuanced working if we were working with Charu instead of Chiku. Okay, I'm getting rid of this Charu working because I need space for the second subpart of this question. Next, if Charu and Chiku are running in opposite direction, wonderful. What is the shortest distance in meters between Charu and Chiku along the circular path when Chaman reaches point B for the 5th time? Now see, Chaman starts from A, 1, 2, 3, 4, 5, 6, 7, 8, 9. When he has traveled this diameter 9 times, when he has traveled the diameter 9 times, that is when he has reached B for the 5th time. Diameter was 1050. He has to travel this distance 9 times at the speed of 35. So 270 seconds have passed. 270 seconds have passed. In 270 seconds, these people are going, one person is traveling at the rate of 15 for 270 seconds. 27 into 15 is 405. 0. This much distance one fellow has traveled. The other fellow has traveled how much? 25 into 270 or 6750. So understand from perspective of Chiku, where is he? From starting from A, 3300 gone, 750. He is 750 meters away. When Shaman reaches B for the fifth time, this is where Chiku is, 750 meters away from A. Now where is Charu? It has traveled 6750. 6750, 3300 once, 3300 twice, 3300 once, 3300 twice. It has traveled 150 meters more than 6600. This is where Charu is. Now see the minimum gap between Chiku and Charu. Minimum gap between Chiku and Charu will be this 750 and this 150, which is 900 meters. It will be this 750 and this 150, which will be 900 meters. On the opposite side, you will get 2400 meters. And we were looking for the shortest distance. The answer to the question will be 900 meters. Okay. Next question. In a 4000 meter race around a circular stadium having a circumference of 1000 meters, the fastest runner and the slowest runner reach the same point at the end of the 5th minute for the first time after the start of the race. All the runners have the same starting point and each runner maintains a uniform speed throughout the race. If the fastest runner runs at twice the speed of the slowest runner, what is the time taken by the fastest runner to finish the race in minutes? Now understand, this question will be difficult to solve if you try to solve it just from the initial statements, but from the subsequent statements it will be fairly straightforward and easy to understand. One thing, 4000 meter race with 1000 meters, so there are 4 laps, 4 circumferences that have to be done. Now we are told fastest runner is running at speed of twice the speed of the slowest runner. So let's say the fastest was running at the rate of 2 and slowest was running at the rate of 1. If the ratio of the speeds is 2:1, they will only have one meeting point, which is the starting point. And when would they meet? When the faster guy has taken 2 laps and the slower guy has taken 1 lap. Additionally, they meet for the first time. They reach the same point at the end of the 5th minute for the first time after the start of the race. They meet for the first time after 5 minutes. So the faster guy has taken 2 laps in 5 minutes and the slower guy has taken 1 lap in 5 minutes. The race was of how many laps? 4 laps. The faster guy is taking 2 laps in 5 minutes. So he will take 4 laps in 10 minutes. Answer to the question is 10. That is all that this question demanded. No calculation per se. It was only interpretation along the way. Next. 2 astronauts, Vaibhav and Kanishk, land on a spherical shaped meteor of diameter 7 kilometers, which is rotating about its own central axis at 2.5 km per second. Equator is the maximum circumference possible on a spherical shaped meteor. Vaibhav starts running along the equator at 20% of the speed of the meteor in a direction opposite to the direction of the rotation of the meteor. Kanishk, standing at a point from where Vaibhav started, records the time taken by Vaibhav to reach the starting point once again. Calculate the time recorded by Kanishk. Now while this is a circular motion, I am sure a lot of us would have been perturbed by what exactly is this happening here. This is a very simple question. Very simple question. The first learning, and this is about bodies moving in an environment that have an influence. If both the bodies that you are observing are within the same environment, the influence of the environment has no impact on the relative speed. When 2 boats are traveling in water, whether one is upstream or downstream, the relative speed is not affected by the influence of water. Similarly here, because both of them are on this special planet, the speed of rotation of the planet is immaterial in time calculation. All we need is what is the distance that Vaibhav had to run. He has to run one full circumference. Diameter is given as 7. So the length that he has to cover is 22 kilometers, or pi d is equal to 22 by 7 into 7, cancel. He has to cover 22 kilometers. Now Vaibhav is running at the speed along the equator at 20% of the speed of the meteor. Speed of the meteor was 2.5 km per second. 20% of this is speed of Vaibhav, which is 0.5 km per second. So he's running 22 kilometers at the speed of 0.5 kilometers per second. How much time will he take? 44 seconds, and that is the entirety of this question. The speed of the planet and the rotation about its central axis and all of that is simply a distraction. This question had nothing to do with the central axis movement and everything. Okay, last question, absolutely the last question. 3 persons ABC whose speeds are in the ratio 3:5:7 respectively started running simultaneously in the same direction from the same point on a circular track whose radius is 105 by 2 pi kilometers, which means circumference of the circular track is equal to 105 kilometers. 2 pi will get cancelled. Remember, this is the radius, this is not the diameter. What is the absolute difference between the distance traveled by A and the distance traveled by C when all 3 persons meet for the first time at any point on the track? Okay. I'm saying the ratio of distances, ratio of the speeds are given as 3 and 5 and 7. I'm taking let their actual speeds be 3 kilometers per hour and 5 kilometers per hour and 7 kilometers per hour. So A and B will meet after 105 by 2 or after 52.5 hours. B and C will meet after 105 by 2 or 52.5 hours, and A and C will meet after 105 by 2 or 105 by 4. This 2 comes from 5 minus 3, this 2 comes from 7 minus 5, this 4 comes from 7 minus 3. Now LCM of these 3 is simply going to be 105 by 2 or 52.4 hours. These people meet for the first time. These people meet for the first time after 52.4 hours, after 52.5 hours. And in 52.5 hours, how much distance does A travel, how much distance does B travel, and how much distance does C travel? All of that can be calculated. Let us go ahead and calculate. 52.5 into 3 gets me to 157.5 kilometers. This is the distance traveled by A. B would have traveled 262.5 kilometers and C would have traveled 17.5, so 367.5 kilometers, or the gap between A and C is going to be 210 kilometers. We could have directly come to this 210 kilometers by simply taking the difference between the ratio numbers 4 into 52.5, 210 kilometers. The problem is 210 is not present within the options, and therefore the right answer here is none of these. Hopefully these questions, these wordings, these framings of versions of questions were useful for you and you learned something. That will be all for questions of this week. Next week again we will be doing some TSD, more to do with upstream, downstream and similar ideas. Hopefully you learned something. That will be all. Have fun. Okay, bye.